Welcome, everyone. I'm excited to kick off our presentation today with our first slide, titled Computer System Overview. In this session, we'll explore the fundamental components and functions of computer systems. We'll cover what makes them work, from hardware to software, and how they interact to perform a variety of tasks. I promise it'll be informative and engaging, so let's get started. Let's explore the different types of software, starting with computer memory, which is essential for how a computer functions. We have RAM and ROM, each playing unique roles in processing and storage. Then, moving on to mobile organization, which refers to how mobile devices are structured and managed. Next, we revisit computer memory, emphasizing its importance in overall system performance. The storage unit is also crucial because it's where data is stored long-term, whether on a hard drive or solid-state drive. We'll look at the working hierarchy within a computer, understanding how different components coordinate to perform tasks efficiently. The CPU, or Central Processing Unit, is the brain of the computer, executing instructions and managing operations. Interestingly, the storage unit is mentioned again, highlighting its significance in the system. Lastly, we'll tie everything together by looking at the overall hierarchy in computer organization, which helps us understand how all these parts work together seamlessly. This slide helps us grasp the core components and their functions, setting the foundation for understanding how computers operate. Let's start by talking about the input unit. This component is responsible for accepting data from users or other sources and converting it into a form that the computer can understand, which is binary. Think of it as the computer's way of listening and translating what you give it into zeros and ones. Moving on to the storage unit. This part of the computer is like its memory. It stores both data and programs that are needed for processing. Whenever the computer needs to access information quickly, it retrieves it from this storage. Finally, we have the output unit. This component displays or presents the processed information back to us. It's how the computer talks to the user, showing results in a way we can easily understand. Together, these units form the core of how a computer interacts with data, from input to processing and storage, and finally to output. This flow is essential to understanding how computers work seamlessly to perform complex tasks. Now, let's look at the output unit, which is responsible for converting the computer's binary output into a form that we can easily understand. Think of it as the translator that makes sense of the machine's language for us. Next, we have the output unit itself. This is where the processed data is presented back to us in a human-readable form. Moving on, the input unit is crucial because it takes the data or commands we give and converts them into binary, so the computer can understand and work with them. Both the input and output units together form the input-output unit, which acts as the interface between us and the computer. To make this clearer, let's look at some examples from the table. The first example is adding two numbers, 2 and 3. When we give this instruction, the system converts add 2 and 3 into binary data, processes it, and then provides the result. The second example involves printing the message, "Hello World." When we request this, the input unit takes the command, converts it into binary, and once the computer processes it, the output unit displays the message in a way we can read. So, in essence, the input unit prepares our commands and data for the computer, and the output unit translates the results back into a human-friendly format. This cycle is fundamental to how computers communicate with us effectively. Now, let's talk about what the ALU, or Arithmetic Logic Unit, actually does. It performs both arithmetic operations, like addition and subtraction, and logical operations, such as comparisons. These are fundamental tasks in processing data. After completing these operations, the ALU sends the results back to the memory, ensuring that information is stored correctly for further use. Think of the ALU as the brain's calculator. It handles the core computations needed by the CPU. This process is crucial because it allows the computer to perform complex tasks efficiently and accurately. Now, moving on to registers, which are small units of data storage within the CPU. They hold important information temporarily during processing. These tiny storage spots are essential because they allow the CPU to quickly access and manipulate data without constantly fetching from the main memory, which saves time and speeds up operations. In essence, registers and the ALU work together as vital components of the CPU, supporting the overall theme of how the computer processes and manages data seamlessly. Let's take a closer look at how the control system works. Controls and guides are essential because they determine how all the data and information are interpreted, how the flow is managed, and how the data can be manipulated. Think of it as the brain's command center, making sure everything runs smoothly. The control unit, or CU, is at the heart of this process. It directs operations, telling the memory what to do and when to do it. Memory, on the other hand, stores the data and instructions needed for processing. Together, these components coordinate to ensure that the system functions efficiently and accurately, supporting the overall goal of seamless data handling and processing. Let's talk about computer memory. First, it's important to understand that memory is where your computer temporarily stores data that it's actively using. This allows for quick access, which is crucial for performance. Think of it as the computer's short-term workspace. The more memory you have, the more data your computer can handle at once, making everything run more smoothly. There are different types of memory, like RAM, which is the most common for active tasks, and storage memory, like hard drives or SSDs, which hold data long-term. RAM is much faster than storage but is volatile, meaning it loses everything when the power is off. So, when we talk about memory, we're really talking about how efficiently your computer can access and process information. This ties into the overall theme of understanding how computers work and how we can optimize their performance. Memory plays a vital role because it directly impacts speed and responsiveness. So, in essence, the better your memory setup, the more capable your computer is of handling complex tasks quickly and effectively. Let's talk about computer memory. Specifically, RAM and ROM, or random access memory, is like the computer's short-term memory. It temporarily stores data that the CPU needs to access quickly while you're working on tasks. The more RAM you have, the more applications you can run smoothly at the same time. ROM, or read-only memory, on the other hand, is a type of memory that holds permanent instructions, like the computer's startup process. It's non-volatile, meaning it retains information even when the power is off. This distinction between RAM and ROM is crucial because it highlights how computers manage different types of data, some that change frequently and others that need to be preserved. Connecting this to the overall theme, understanding these memory types helps us appreciate how computers balance speed and permanence to operate efficiently. Now, let's turn our attention to the storage unit. This is a crucial component because it's where all the data actually lives. Think of the storage unit as the backbone of any system. Without reliable storage, everything else falls apart. The key points to remember here are the different types of storage available, such as hard drives, solid-state drives, and cloud storage. Each has its own advantages in terms of speed, capacity, and cost. It's important to understand that the choice of storage impacts performance, scalability, and even security. For example, cloud storage offers flexibility and remote access, but might raise concerns about data privacy. On the other hand, local storage provides faster access but can be limited in capacity and more costly to expand. Connecting this to the overall theme, the storage unit is what ensures your data is safe, accessible, and efficiently managed. Whether you're dealing with large datasets, applications, or backups, selecting the right storage solution is fundamental to building a robust system. So, understanding these options helps us make better decisions to support our infrastructure's stability and growth. Let's take a closer look at the storage unit. This is a crucial component because it holds all the data that our system needs to operate efficiently. Think of it as the backbone of our storage infrastructure. It needs to be reliable, scalable, and fast. When we talk about storage units, we're referring to both hardware and software aspects, like the physical drives, the way data is organized, and the protocols used to access it. The key points here are capacity, speed, and redundancy. Capacity ensures we can store everything we need without constant upgrades. Speed is vital for quick data retrieval, especially when dealing with large datasets or real-time processing. Redundancy, on the other hand, safeguards our data against hardware failures, making sure that a single point of failure doesn't lead to data loss. Connecting this to our overall theme, the storage unit is what enables us to handle big data efficiently and securely. Without a robust storage solution, even the most advanced processing systems can falter. So, understanding the storage unit's role helps us build a resilient and scalable infrastructure that supports all our other components seamlessly. Now, let's talk about mobile organization. When it comes to managing mobile content, the key is flexibility. We need to ensure that our information is not only accessible on the go, but also organized in a way that makes sense, no matter where we are. This means designing with mobile users in mind, simple navigation, quick load times, and clear hierarchies. It's important to highlight that a well-structured mobile organization enhances user engagement and supports our overall goal of seamless communication. By thinking about how people access our content in different contexts, we can create a more effective and user-friendly experience that aligns perfectly with our broader strategy. Let's take a moment to understand the working hierarchy in a computer. At the top, we have the Central Processing Unit, or CPU, which acts as the brain of the computer. It controls and coordinates all the activities. The CPU communicates with memory units, like RAM, which temporarily store data and instructions that the CPU needs quick access to. Below that, we have input and output devices, key components that allow us to interact with the computer. Input devices like keyboards and mice send data to the CPU, while output devices such as monitors and printers display or produce the results. Within this hierarchy, data flows from input devices through processing units, then to memory, and finally to output devices. This organized flow ensures efficient operation and quick response times. Understanding this hierarchy helps us see how all parts of a computer work together seamlessly to perform complex tasks. So, in essence, the working hierarchy in a computer illustrates the structured flow of data and control among these components, which is fundamental to the overall functioning of any computer system.